Welcome! Today we will be looking at a sapling problem from topic 14. In topic 14, we looked at how to compute stoichiometric calculations. More specifically, today we will be looking at a limiting reagent problem. The problem consists of several different parts, but we're going to go through each of them step by step. The first part of the problem reads, cryolite, an ore used in the production of aluminum, can be synthesized using aluminum oxide. Balance the equation. You should already be familiar with balancing equations, so we're going to quickly balance it for you. If you're not sure how we did this, please go back and review topic 5. The second part of the problem reads, if 10.2 kilograms of Al2O3, 60.4 kilograms of NaOH, and 60.4 kilograms of HF react completely, how many kilograms of cryolite will be produced? This is asking us to find the limiting reagent, and based off of that, determine what is the maximum amount of cryolite we are able to produce. To do that, we first need to convert kilograms to grams. We are going to start with Al2O3. We have 10.2 kilograms, and we want to convert that to grams. We multiply 10.2 kilograms by 1,000 grams over 1 kilogram, which is the conversion factor, and we get 10,200 grams. We follow the same procedure for the remaining reactants. For NaOH, we get 60,400 grams, and for HF, we also get 60,400 grams. Next, we find the molecular masses for the reactants and product. For Al2O3, we have 2 aluminum atoms and 3 oxygen atoms in one molecule. Therefore, we multiply the molecular weight of aluminum by 2 and the molecular weight of oxygen by 3. When we add them, we get a total molar mass of 101.96 grams. We follow the same procedure for the remaining reactants and product. For NaOH, we get a molar mass of 40 grams per mole. For HF, we get a molar mass of 20.0064 grams per mole. And for Na3AlF6 cryolite, we get a molar mass of 209.94 grams per mole. We will use the molar mass of the products a little later. Now that we have the grams and the molar masses of the reactants, we can find the moles. For Al2O3, we will multiply the grams by a conversion factor to moles. The conversion factor we will use is going to be moles over molar mass. In our case, the conversion factor will be 1 mole over 101.96 grams per mole. When we set it up, we will get 10,200 grams multiplied by 1 over 101.96, which gives us 100.04 moles. This means that 10,200 grams of Al2O3 is equal to 100.04 moles of Al2O3. We follow the same procedure for the remaining reactants. For NaOH, we get 1,510.11 moles, and for HF, we get 3,019.03 moles. Now that we have the moles of each of the reactants, we want to see how many moles of the product will be produced. We will start with Al2O3. If we look back at the balanced equation, we see that the ratio between cryolite and Al2O3 is 2 to 1. This ratio means that for every mole of Al2O3, 2 moles of cryolite will be produced. To find the number of moles produced of cryolite, we multiply the number of moles of Al2O3 by the ratio 2 to 1. We get 200.08 moles of cryolite produced. We follow the same procedure for the remaining reactants. For NaOH, we get 3.37 moles of cryolite produced, and for HF we get 503.17 moles of cryolite produced. To find the limiting reagent, we look to see which reactant has produced the least amount of cryolite. In this case, Al2O3 is the limiting reagent. The rest are called excess reagents. The next part of the question asks how many kilograms of cryolite will be produced. Since Al2O3 is the limiting reagent, we are only able to produce 200.08 moles of cryolite. We now have to convert moles to kilograms. To do so, we first convert moles to grams by multiplying by the conversion factor. Molar mass over moles. We have already calculated the molar mass of cryolite. After we multiply the moles by the conversion factor, we get a total of 42,004.79 grams. To convert grams to kilograms, we multiply the number of grams by the conversion factor of 1 kilogram over 1,000 grams, giving us 42.005 kilograms. There will be a total of 42.005 kilograms of cryolite produced. The next part of the question reads, what is the total mass of the excess reactants left over after the reaction is complete? We know that the limiting reagent is Al2O3. It is going to be consumed completely in the reaction. We are now interested in finding out how much of the other reactants we need in order to completely react with 100.04 moles of Al2O3 and not have anything left over. To do so, we multiply the moles of the limiting reagent by the ratio between NaOH and Al2O3, in this case 6:1. We get 600.24 moles of NaOH. This means that we only need 600.24 moles to react completely with the 100.04 moles of Al2O3. But we have 1,510.11 moles of NaOH. To find out how much is left over, we simply subtract, getting 909.87 moles of NaOH left over. We convert the moles to grams. We follow the same procedure for HF. Once we have found the amounts of excess reagents left over in grams, we simply add them up. We then convert to kilograms. We get a total of 72.784 kilograms of the excess reagents left over after the reaction. So let's summarize. We first converted kilograms of each of the reactants to grams. We then found the number of moles by dividing by the molar masses. Then we found the limiting and excess reagents by multiplying by the ratio. We then found how many moles of the excess reagents we would need to completely react with the limiting reagent. And we then found how many moles of the excess reagents were left by subtracting how much we need from how much we originally had. Finally, we converted moles of grams to kilograms. And we're done. Thank you for watching.